Hello, everyone. I know it's been a while. I think it's probably 2, maybe 3 weeks, if I'm not wrong. Today, we're gonna do something similar to the last time, and I'm very excited about it. We will continue our series about antivirus engine evasions. You will might probably ask, why am I so excited? Well, I find it super interesting in general, not only antivirus, but generally malware and learning how to do stuff that you've never done. Um, in the previous session, in the previous live, um we explained this. We will do also a brief explanation again. Uh, Sorry about the delay. I was trying to live stream, but I had some technical issues. I still do have them. I hope they get fixed. In my Twitch live, I cannot check if it's worked correctly from both my computer and my laptop. And the YouTube like took a while to load, but now I think we are good. I hope. I hope so. Maybe yes, maybe no. I guess we'll find out. Okay, so let's fire up Visual Studio. I have a brand new virtual machine that we will do the testing. I have disabled the antivirus, so I hope everything's fine. Uh, sure. Actually, no. Just dark theme. Dark theme is fine. Oh, okay. I have it saved. Okay. So in the previous session, we explained the libraries that were included. This is a payload for a calculator. We we also saw that the wait, okay. We also saw that the what did we say? Yeah, this was the calculator, the payload for the calculator. We initialized a variable for its length with the size of. So this essentially just calculates how many of these exist, and it just tells the size like this is 50, this is 80, or whatever, whatever. Um, what else? Then we also initialized some more variables. Why is this red? Argue of type unsigned integer is compatible with constant void C++. I don't know why, but let's ignore it for now. For now, of course. Did I wrote something wrong? Is there a way to fix it? Probably not for now. Okay. So we initialize the memory, the buffer, the memory buffer for the payload. So this essentially creates a space. Let's blackboard line. To my understanding, always to my understanding, skip. Come on, please. Load. No. Yeah, no, please. Okay, perfect. So essentially, I think this is like a buffer, and this just creates a new space, like in between, and it says it that the memory address will go here, like whatever address, like 0, 1, for example. This just creates a memory buffer for this payload. Like buffer, if we search how it is, it's gonna be like visual representation. Yeah, okay, so essentially it's like oh yeah, I think this is better. It's like the memories, like this is the whole buffer or else the memory. And you can just create a space, like choose like this space right here, and we will allocate it for the use of this payload. So this is gonna be the payload right here. We will allocate it with the virtual alloc. We will move the memory. What hell? I don't remember what that is there. Allocate. It will copy this from memory to the buffer. So essentially, there's gonna be a memory, and we're gonna copy this from memory to the buffer, and it's gonna be executed. The this will make the virtual protect will make it executable, like change it from read and write to execute and read. And lastly, it will run it by creating a thread. A thread is actually, um, let's go back. Okay, so let's assume that this is a process. What, you may ask, what's a process? A process is something that it's gonna be executed, and inside a process, you can have multiple threads. There is like a whole thing called multi-threading where threads are executed simultaneously, and a process is something that wants to be done. Um, so what else? I think that was it for the first one. We took like an hour to explain it because I analyzed it. I hope I did a good job. I might have not. So now let's move on to part two. I think there are a lot of parts. I have seen like there are six. I have not read them thoroughly. I have just like seen that they exist. So we will see them together. I have read the part two. Don't really remember everything about it, but I have read it. Okay, so what do we do? Hello, hello again. This is not a tutorial how to make marble per practice. Okay, perfect. This is for practice. This is the second part. Okay, we did study it. And in this post, we will start. I hope you can see the screen. If you can't, please kindly let me know, even though there is no one. Uh, Okay, I think you can see it. Okay, I know there is no one, but I'm still gonna say it. Um, in the second part of the story, I'll comment. Okay, in this process, finally called obfuscation. Okay, anyone wondering what obfuscation is? If you're a complete beginner, obfuscation essentially just hides the code by changing its values. I think that's the definition of obfuscation. Let's search it together. The act of making something obscure, unclear, or unintelligent. Like if you say a variable is gonna be like calculate, um, calculate the sum, example, and instead of doing this variable, you say this. If anyone understand what this means, good for you. But if you don't, and you're a normal human, and, and you're a normal human being, you would prefer this. So essentially, obfuscation just makes this to this. I hope this was clear. Let's see if there's a miscommunication by making the message difficult to understand. So yeah, essentially the variables instead of being like my payload is gonna be something like this, where you don't understand a thing. But this and that were the exact same thing. Let's consider our variable exe from part 1 in virus tutorial. I hope it's still there. Yeah, it is. Okay. We see there are a lot of flags hidden for like Trojan, malware, etc. From a lot of how do you say it? A lot of and not antivirus exactly. Security vendors. Okay. So we could clearly see that it was a bad malware because everyone could see it and like a simple antivirus could find that it was malware. It's also that the create thread in here. If you go to details, in the kernel 32, we could clearly see the create thread and the Wait for single object. Yeah. So wait for single object just waits for space to be available for the CPU to execute it and creates a thread for it to be executed. Okay, so we don't want it to see every module. Mo so those libraries can also be called modules. If I'm not wrong, P module like X and usual are using. Okay, let me correct my if I don't understand correctly. What is what is a module? A module. It's a set of standard. Okay, complex structure. Programming. A discrete unit code that encapsulates specific functionality. Okay, I don't understand what does that mean. A section code that's added as a whole. Okay, so that's like an API. So it's like a library. Is module like a library. Module is a piece of code that may be built upon a package. Okay. Okay, so essentially a module can be a part of a library, a group of modules. Okay, so this is like part of structures. P module like .exe and .dll, which are the two most known for executables, usually include external functions. Also, yeah, external functions like create, thread, and wait for single object, which are right here in the windows.h. And I find them where they are. Wait, wait for single. Oh, there are no results. Okay, create. No, is it not here? Okay, that seems interesting. It might be inside of another one. Is it maybe in this? Create, no. Okay, let's forget about it. Um, so when it runs, it will call every function implemented as an external DLLs, dynamic libraries, which will be mapped into a process memory to make this function available to the process code. Okay, so what does it says that in the kernel authority do DLL, there are how is it? Functions like create, thread, and wait for single objects, and a lot more. And all of them are like functions that we don't use, like get, last, error, virtual query, will all be included in our code. And we don't want that. Um, Everything else in Excel we mapped, okay. AVI additionalize most kind of external DLLs and functions are used by malware, okay. It can be a good indicator if this binary is malicious or not. So AV engines analyze a P file on a disk by looking into its port and address. Okay. Of course, this method is not bulletproof and can generate some false positives. To work, okay, false positive for anyone wondering is like when something is shown as positive and it's negative, and false negative if it is negative and it should be positive. Essentially, I think false positives are more rare, and uh, it's no false positive for negative. Okay, false negative, I think is the bad one because imagine if an attacker attacks your company and it says it is not a hacker, you don't want that. This is called a negative. So you want to actually have a positive that it is an attack. So that's bad for the company. It is also not work some cases. Okay. So what we do as malware developers can we do about this? This is where we call obfuscation. Okay. function call obfuscation, a method of hiding your DLLs on external functions that will be created during runtime. Okay, so I said it's gonna just change everything to this. It will probably change the payload so it won't be understandable. Like this just calls the calculator and we won't know it. Okay, it's kind of annoying me, so let's just Google why this is not working. Um, Unsigned int is incompatible with parameter of type const void pointer. Let's use Stack Overflow. Come on. What did we do wrong? It needs destination, so the memory. Mem of destination source expands the. Okay, did we? No. Did we put more? No, we don't want CUDA. Okay. RTL move memory error. I will just give it like 5 minutes, and if I cannot find what the problem is, I will move on. So please excuse this delay. As well. Copy memory is passed. Okay. Oh, so it says that this goes. I think the problem is that this goes nowhere. If I do a equals this, it's gonna fix it? No? Okay. No. Argument of type unsigned int. Which one is unsigned int? Unsigned is my paperload memory. It's void. This is a pointer. Is this wrong? My payload? No, this is a pointer. Okay. So I just wrote it down wrong. This needs to go. Here's my payload. So this fixes it. Okay, I'm just not the sharpest tool in the shed, I think it's expression. And I just was a mistake, but let's ignore it for now. Where are we in the second? Let's go for this. Okay, let's compile it like he does. Have I? Please don't tell me that I have forgotten to GCC. Oh my god, I have forgotten to install GCC. Oh no, that's pretty bad. Well, I'm not gonna do it in right now. Okay, yeah, I'm not gonna do it right now. I'm gonna have it prepared for the next stream. But for now, let's just move on. I will explain it, and in the next time, I will just execute this code and the code in this, and I might go for the part 3 as well. Okay, so we were In here, call obfuscation is a method of hiding DLLs, okay, that we'll call that during runtime. To do that, we can use standard Windows API functions called getModuleHandle and getProcAddress. What does this do? Retrieves a module handle for a specified module. The module has the module must have been loaded by the calling process. Okay, so we first need to load the process, and it will retrieves a module handle. Okay, so it will retrieve a handle of a module of a specified module. And get proc address, what does this do? Retrieves the address of an exported function, as also known as procedure or variable from a specified dynamic link library. Okay, so this just gets and I wanted address from a DLL. It takes the module name and the process name. Okay, let's see where this goes. The former, it explains here. Okay, the former returns are handle specified DLL. Okay, and the latter allows you to get memory address of the function. Okay, so essentially this returns the handle and this gets the address of it. So let me give you an example. Let's say your program needs to call a function called hack and win, okay, which is exported in a DLL named hiker.dll. So first you call get module handle, okay, and then you call get proc address with the argument of hack and win function and return, and in return you get the address of the function, okay. So it initialize a variable. The firstly the get module handle will load the library, and the get proc address will get the hack and win from the hiker DLL. Okay, so what is important here is that if you compile your code, compiler will not include hiker.dll into import address table. So antivirus engine will not be able to see that during static analysis. Oh, okay, so this just bypasses importing it from hashtag include. No, we will see what it does different. Um, is that if you compile your code, okay, compiler will not include hiker.dll. Okay, so if you include a DLL here, it will not be included in your code, and the antivirus engines and the virus total will not be able to see it into the import address table. Okay, so imports are here, so this will not be able to see the import. Fun fact, I have installed pbear to see it, but I forgot to do the compiler to actually see the code. So that's good. And but okay, let's see how we can practically use this technique. Let's take a look at the source code, food, the source code of our first malware. Okay, we have the same. I will create a new one, malware with v2 C++. I will copy and paste right here. So this until here it's the same. It's the same until here. Also allocates it. Okay. Is there any change? Oh, this is exactly the same code. So this code contains very basic logic for the execution payload. Okay. So in this case, for simplicity, it is not encrypted payload and it's plain payload. Okay. Let's compile it. Okay, I cannot compile it for the previously set reason because I forgot. So let's take a look into the input address table. I don't have the executable to do it. So that's great. So essentially what you will do is go inside the CMD and she will. Can I actually do object dump in here? I think you need Linux. No. Okay. Let me try to fire up my Linux workstation and I will share my screen there and I will see if I can actually do it. Although I don't know if it can understand the Windows.8. I hope it can. If it can, that's fine. As you can see in our program, it uses kernel 32.dll and imports all this function. Okay, is it fired up? Okay. Let me change it from this to this. Yeah, okay. You can probably see it. So let's go CMD. Let's see if I can just copy and paste. Do I have this? Let's see how that GCC. Okay, yeah. Um, what was it? Cocom, let me see. Let's just, can you copy? No, okay. Let's just copy and paste it. Copy it from here, go up, copy, let's go to downloads. Let's make a directory called malware. Let's see the malware. Let's clear it. And let's do codium malware.c++. Codium is similar to VirtualBox, as you can see. Why do I have? Oh, okay, yeah. I have tested like the next one because I want to see what it does. I as you might understand, I cannot actually execute the code because it is for Windows, but I think I can actually G++ the malware. Let's save it. Okay, it does not understand Windows.8. Yeah, I remember I wanted to do it in the Linux, but I cannot do it because of the Windows.8. If I actually remove it, I think it will break. Yeah, it does break because it doesn't understand anything. So it needs it. I don't know if there is a way to bypass GCC ignorers. Is there a way? A return stack address. Let's try this. It's not gonna work, but I understand. Ignore library errors. Please stop doing that. Is there a way? Where? My things on. Will ignore word from hub. Okay, yeah, please. Now can use one size system. This is the minus I system malware malware management. Malware. Again, no input. What? Okay, yeah. What does he do here? Don't understand a thing. Okay, let's man this thing. Language, no. Database, no. Pipe wrapper. C++, no access. Where is the no library? F module header. Either way, don't know. Linux base. Okay, this this is the no C plus libraries. Okay, yeah. Play. Is there anything? And you may try and include libraries conditions. Okay. What hosting directories. Windows updates. Okay, how to GCC Windows updates from Linux. So away. Okay, have it, then copy. How to use, okay, in the Linux. I know you about to might hate me, but is there anyone in? I don't see anyone inside, so no one can complain to me. So for now, it's my life. Sure. Step to use, okay, I have it downloaded, then copy to the project directory. How am I this? CP, okay, let's try it. ls, and let's go cd slash user slash lib slash gcc. Okay, there is something. cd here, ls, cd13, ls, then there's a DL, is there a DLL here? Is there libgcc, libstd, lib, is there a lib for the gcc, sdc++, no, no. I don't have many. No, there is only 13. libgcc. Oh, here it is. But it's not a DLL. It's dot A. I don't know a dot what. Let's go and include directory. Is there anything? Is there DLL now? Um, no, maybe do you have a G plus plus? This is it. Git, no, okay. Okay, let's just forget about it for now. In the next time, I know I have said it like 2 times. I will actually try to compile it correctly and not be a dummy. So as you can see in our program, the object dump just dumps uh, the binary, dumps the binary. Object dump displays information about, okay, displays various information about a Unix operating system. Okay, yeah, I have seen it, but doesn't it actually show also the binary? No. Yes, it shows some. Yeah, okay. It shows the assembly code. Where was I? Okay. It essentially just opens this decompile it, if I'm not wrong, and manchecks. What does mancheck do? Manchecks. Let's see the command. Come on, I don't open the my Linux again. Okay, let's just use less information and you can just continue if you want. Okay, sure. Where is manage F, manage P, manage set, manage set display all headers. Okay, so which are the headers? These are the headers, like the loud dynamic section. I'm not sure. Probably this. This is the program headers. The minus D just disassembles it. Right, for disassemble. Minus D disassemble all sections. Minus D small disassemble display the assembly code of an execute. Okay, so this will do just the executable part, and this will do the whole thing, like interpret node. Just have it? No, it just has init initialize, PLT plot, printf the function for the to print something. As you can see in our program, it uses counter to do DLL and import all these functions. Yeah, you can see it here as well as here, which is the antivirus, the virus tutorial. And some of them are used in our code. Yeah, virtual unlock, RTL move memory, virtual protect, create thread, and wait for single object. Okay. Let's let's read. Let's get rid. Okay. Let's get rid of virtual unlock. So how can we do it? First, I'll going to find the declaration virtual unlock. He does it, but we can just do virtual unlock. If you want to search it, go here. If it wants load, if it doesn't, that's fine. And you can see like it needs to take 4 variables: an LP address, uh, as a DW size, an allocation type, and a protection. It doesn't want it. In our example, the the first one, the address is gonna be 0. The size is gonna be the length of the payload. Then it's gonna be the allocation type, which is gonna be a commit and a reserve. And lastly, the protection, which is like the read and write. I don't know what call protection. Make sure this is implemented carefully to DLL. Yeah, okay. If you don't have the authority to DLL, you could not actually do any of this. Not the virtual unlock, not the memory. Um, then what is then? Okay, but it has to be a pointer. Okay, let's create a global variable virtual unlock. Okay, so it's gonna be void lp void. No, the want part two. lp void win API times the virtual alloc. No, it's gonna be the p virtual alloc. So it's like it's a pointer, and it's gonna take the LP void. So it's the exact same thing as like in here the virtual location. So we just make a pointer to this. To essentially, it points to a virtual allocation. LP void LP address size t dw size. What does w set t do? Set t and store a maximum of 30 plus. Okay. A specified unsigned integer type definition in a standard library. Okay. It is the type of the result returned to the size of it my boss to allocate. Okay, so this just sets the maximum to the maximum possible size. Okay. Like you could say like to 100, which gonna be the you won't need any more. The word is double word that was said. FL allocation allocation type and the D word FL protect. And question mark of course in the end. And now we will need to get the address. To get this address via getproc address, which we discussed it in the beginning. It's gonna be instead of the virtual unlock and the no, not instead of the RTL move, only instead of the virtual allocation. So instead of doing it in one go, so in order to minimize how many flags will be hit in the antivirus, we will want to change it to a pointer virtual alloc. It's gonna be the get proc address, and this will get the module handle. It is the same thing as you said above, like right here. So this will get the DLL, and this will call a function inside this DLL. To my understanding, again, if I'm wrong, just comment it or send a message to me right now. It's gonna take the kernel 32.dll, and from this we only want the virtual alloc, and boom, that's it. Kernel 32. What is the problem again? Okay, let's see what I did wrong. Get proc address, get module handle. Okay, we're correct. It gets the kernel 32.dll, and this is given to virtual alloc. Okay, what is there anything? I will just check it in a sec. Let's close this, and the payload memory will be initialized with the value p virtual alloc, Um, oh, it's gonna be the same as before. It's gonna take all of this. Again, same logic. Why is okay? This will this just initial this is just the same thing as the virtual alloc itself, but instead of being an virtual alloc, it is initialized here with the same not demands, but the same what's the word? Not variables. Let's just say variables. Why is the Win API? What? Win API. The Windows API creates a user. Okay, why is there a multiplication? I don't understand that. And let's see why this is wrong again. Argument of type constant char is incompatible with LPCWSTR, aka const W char. Is it not what I wrote? Let's see the code below. Those are probably, yeah, this is the full code. No, this is a changed code. Um, where is it? It's here. So it's gonna be LP. Okay. Virtual log address, size T, D word, and D word. Okay, so this is correct. And in here, the P virtual allocate a memory buffer. The P virtual alloc. Why can this not be? This is the function. We want essential to pass the virtual alloc to that. Get module handle. If I remove this and type it again, kernel DLL. If I just do like this is not initialized. Let's say that this unnamed. Does this fix it? No. No, this does not fix it. The value and get proc address. Get module handle. Kernel 32.dll. We do it, put a comma in here. It is inside the parentheses here. Okay, I don't understand why this is not correct. Okay, let's just move on. A type varproc aka long cannot be assigned to an entity of LP void. This is the problem. LP void cannot be a value of varproc. What is a varproc? Is a generic function pointer. Okay. A value for a generic aka long cannot be assigned to an entity of type LP void std call times yeah aka void. Why? Does not say why. And here it is incompatible with parameter LPC WSTR. 32-bit pointer to a custom string. Again, not understanding where is the problem. Okay, let's compile. He compiles it, then so no virtual alloc. Okay, so this just hides the virtual alloc. Looks good, but there is a caveat. When we try to extract all the strings from our binary, we will see the virtual alloc. Yeah, because it is in the actual code and not in the imports. This it's not the same. As you can see, it's easier. The reason that we're using the stream is a clear text when we are getting get proc Azures. Okay, so what can we do? So what can we do about it? Probably nothing. Let's say we can remove that. Wait, the reason is that we are using the stream in a clear text where we're getting get proc address. Okay, so what we can do about it? The way is we can remove that. We can use XOR function for encrypt decrypt we used before. So let's do that first XOR function in our evil C++ Marvel source code. Okay, where does he do it? He does it here. It initializes a function that XORs the data. It takes the data under size and also a key and the size of the key. Okay, and it does the basic cryptography of the XOR. For int I equals 0, I is less than data length, I plus plus, if j is equals key length minus 1, then j is equals to 0, not phi, if data I is gonna be data I to the XOR key j. I will explain in a bit what it's probably doing. Okay, now that we have written it, so this initializes a random variable j. It can be x, it can be x, y, whatever you want. And this goes for a loop starting from 0, so meaning the beginning. This will probably done in my payload, so this is actually 0, not 1. This is the 1. So if we started from 1, it will start from here, not from here. So this is done until the previous from last, and then it changes j to 0. The the reason for that is we want to reset the j. The j is gonna actually go for the whole key. We're gonna initialize the key like in a bit, and it's gonna iterate. It's gonna change the data from data to data XOR the key. XOR, if you don't know, is a logic gate where if the variables are different, they give 1, and if they are the same, they give different. So a 0, 0 will give 0, a 0, 1 or 1, 0 will give a 1, and 1, 1 will give 0. Um, so essentially, if the data is the same, it's gonna, I think, change it, and if it's not, it's gonna, I think this will just translate it first. Data I, so it's gonna take this. Okay, so this is an unsigned, this is in hexadecimal. This is the value 252, as said here. And 252 will be translated to binary. So this is gonna be 4 bits, and this is gonna be 4 bits, and it's gonna compare those 4 bits to the 4 bits of the M. The M is gonna be first translated to ASCII. So M in ASCII is 77, and 77 is gonna be translated to bits, to binary. This probably, yeah, this, and it's gonna check the, let's see, 252 in binary. So it's gonna compare this and this, and if it sees 1 and 1, it's gonna give 0, and if it is 1 and 0, it's gonna give 1. So the first two, I'm just gonna say the first two is, it's gonna be 0 1, because this is the same, it's 1 1, and this is different, which is 0 and this is 1. So it's gonna give 0 1, the first two of the first iteration, and it's gonna continue for the whole payload. And for we will create key and some string. Let's say creating a string C virtual alloc below the, where? Let's just do it below here. Unsigned. I will explain again. Unsigned int is actually it will go from it instead of being only for negative and positives, it's gonna be only positives. So assigned is gonna be both negative and positive, and an unsigned is gonna be only from 0 to up. So if you actually absolute this, take the absolute value and add it to this, you get this. So this is the same range as this, but starting from 0 instead of minus this number. Let's pronounce it. This is thousands, millions, 2,648,648. I hope I said it right. And it's gonna unsigned thing. No, you cannot do that. Unsigned char first. I see virtual alloc. This is gonna be an array, an empty one. And we're also gonna do unsigned it, see the length of it, virtual alloc length. And this is gonna be just the size of, let's see, virtual, not length, virtual alloc. Where's the problem again? An empty or initialized? What's the problem? He does the exact same freaking thing. I don't know if I can curse or not. I wanna curse. An empty, there is no specified bound. Great. Where's the problem again? Then let's char my secret key is gonna be dog. Let's be different. Why? No reason. Add XOR decryption. Okay, so this is for decryption. This is not for the encryption. This so we will encrypt the data, so the if a person tries to read it, he cannot. And if we actually, because he will not know the amount, the length of it, we'll probably hide the payload itself and give it to another program. So he will XOR, where in the main? Here. XOR char pointing to a C virtual alloc and the C virtual alloc length with my secret key and its length, size of my secret key, because it's my secret, my dog. And here, instead of the virtual alloc, we're gonna do C virtual alloc. Again, what's the problem, gentlemen? Quick fix? What's quick fix? That's still there. So the final version of our code is gonna be our payload, sure, with everything below it. I'll pivot. This is like the how it should be, and we did the same thing with a pointer here. The acceleration, I think there is not a problem with it below or above. Let's just see if there's a difference. Probably not, but for the hex of it, no, it's the same thing. And here again, the same thing. Here it matters because we first need to do the XOR in here before we actually put it in here. And we also need to put the p-virtual alloc here to, where do we put again? To the memory, which will the memory do you stay below. And we will use the Python script for XOR encryption, encrypt our function name and replace. So this we will encrypt the data in here with a simple Python script. So let's just name it XORation. Why not? .py. We will import some libraries, sys, os, haslib, string. We'll again initialize the XOR with data and the key. The key is gonna be the string of the key. The L is gonna be the length of the key. Yeah. The output is gonna be an empty string. We will do an iteration in the range of the length of the data. So this will go through all the data. Then the current is gonna be the data of the I. So the first thing in the payload, the current key is gonna be the key I length of key. This takes the like the first if this is a 0 and modules through the length of the key. So this just ensures that it will not go over the key, meaning that if the key is like 5, it's gonna be 1, 2, 3, 4, 5. And since the length is 5, it's gonna go again to 0. So if it meaning 5 module 0 module 5 is gonna be 0, 1 module 5 is gonna be 1 until 4, and in the 5 it's gonna go back to 0. This is like the remainder of a division. The ord is gonna be lambda. A lambda function is like a small function that you can initialize in another function or generally wherever you want. It will give x if is instance of if the x is int. This will return x if x is int. Else it's gonna do an ord of x. Ord is, I think it converts the x to from a character to a number. Let's ord python. Return the ASCII representation. Yeah. So if it's 8, it's gonna give 104. And it again the output of the str which we initialize here is something empty. We're gonna change it and we'll do plus equals, this is the exact same thing as doing output str plus. It's the exact same, it's the exact same thing instead of rewriting it. So this is gonna do the char, gonna convert to char, word, which is the function to check if it's an instance or not of the current, and it will power it to the ord of the current key. So current is the data and the current key is the key like dog which we did here. And it will return the output. Then we can do the encrypt. This is the to encrypt the data. This is to encrypt the text. Let's just copy and paste because I'm bored to do it again. This just XORs the data and the key. This just calls the XOR from here. It will print 0x but changed. This will join the hex of the ord. This is kinda weird. So ord of x, as I said, will give the uh, okay, ord of x will give us the number representation of a character, and it will hex that character. Hex will change it from a decimal to a hexadecimal, right? Converts, yeah. So let's say you want to compare 8 to ASCII. So this is 104, and then you want to convert 104 to hex. So this is 0x68. So you're gonna get 0x, and then this is gonna be 68, and then it will go from the second. It's gonna start from the second part of the array. So the first is gonna be the 0x, and it will just do the rest. 4x in the ciphertext, and it will just close it. So this is gonna be the in the form of 0x, no, 0x, and it's gonna give like 68, and then it will close if I'm not wrong. I might be wrong, but I don't think I'm wrong. Then it will print the text, and then it will return this and the key. Then we just do the virtual alloc, which is the one we wanted to be encrypted in here. From the that's why we created the C virtual alloc. Then we're gonna encrypt it, encrypt the ciphertext. What? Oh, it's the ciphertext is gonna be the thing given from encrypting this and the secret key. It's gonna give us the P key. What's the P key? It's just gonna return the key that we gave. To my understanding, does not change it. Yeah, it does not change it anywhere, or does it? No, it's the same thing. Um, Open or replace. Okay, so this is some file stuff. So this opens the C++. In our case, it's gonna be malware v2.c++, and it's gonna do read. What's the stuff? I think it's text. C++. Oh no, Python file read. Come on. I think if I'm not wrong, it's read text, because there's also the RB, which is read byte. Will it load? Yeah, it loaded. Let's go here in the file handling. read text. Yeah, it's the text, and B is for the binary. It's gonna read this. uh, It's gonna open this file, then read it and save everything as data. So it's gonna read and save everything to data. It's gonna replace the C virtual alloc with the it's gonna replace the empty string with the ciphertext inside. The ciphertext, as we said, it's gonna be the uh, encrypted virtual alloc, and it's gonna close this file, and it's gonna open a new file called evil encrypted plus. I'm just gonna rename it to malware v2 dash encrypted c++, which is gonna be the encrypted version, and it's gonna do the write. I I really have no idea what plus is. I don't. Python w plus open. So this let's read the difference. Translate file to a zero length or create a text file for writing. Okay. The string is positioned at the beginning of the file. Okay. Open for reading and writing. So this will both read and write. The file is created if it does not exist. Okay, so this is also okay. So if it was W, you need to have a file, but it can also create if there's W plus. Otherwise, it is truncated. The stream is positioned begin. Okay, it's the exact same thing, but it can also create the file and read it. Then it's gonna read the data that are changed, and then it's gonna close it. Pretty simple. Then it's going to try to compile it on its own. So if you just execute this file, it's going to do it. So malware v2 encrypt minus show again. Let's rename it to malware v2 exe function data no write string no exceptions. Could have I done that all along? Yeah. Okay, that's rough. Our system cmd except binary compiled. Okay, so it will try to execute it, and it will if it is successful, it will give it to the OS to execute. If this is successful, it will also go to the else and print it and print the successful compile. If it cannot be done, it will print an error compiling it. He compiles it, and he will run the strings, and he will see that there is nowhere to be seen a virtual alloc, because it is XORed. It is like a different it is in a different name, and under a different name. So you can see it's undercover. This is how you can actually obfuscate any function in your code and can be virtual protect in order to move. So if we change this to virtual protect or RTL memory or RTL move memory, it's gonna do the exact same thing. I think you can just do the exact same thing like 3 times, but you're gonna have to like meaning. You can do this again with virtual protect again. Write it, but yeah. How do I say it? Open. It's gonna read the data again, and it's gonna replace it with this ciphertext here, and then it's gonna close it. Okay, so this should be done also here, and we don't want to. Okay, we want to read it, but we don't want it to be executed. Okay, so we just double do it everything. I don't know if we can skip anything. But for safety, I would just do everything. So I would just do everything twice, basically. Instead of here, actually, we would do it here. Here, yeah, here. I don't know if there's a faster way to do it, but this is a way I just did in my head. Everything is okay. If you upload it, we can see that the antivirus has gone significantly down. We can see that in what? Why is there 54 again? Let's see the details. Let's see in the kernel holiday 2, is there a virtual unlock? There is no virtual unlock. So that's a really good improvement. Is there a comparison in for in the beginning? Yeah, in the beginning it has the same flags, but now it does not have the virtual unlock. This is their difference right now. It changes it. He says it stains, but it's not for me right now, at least. I will also in the next time in the next live, I will also try to compile them and also upload them and let to see whatever. And other factions can be obfuscated to reduce the number of AV engines. If we do, he says if we do like the virtual protect or the ultimate move memory, if we do those two, that more flags will not be shown. And that's all. My project pickup appears. It's okay. Okay. It was a long explanation. I hope I covered everything. I might have not. I might have. I tried my best. Please don't kill the messenger. In the next one, we will do the part 3. There's definitely a part 3. Where is it? I'm sure there is a part 3. Is there? No? I'm 100% sure that there is. No. I'm just wasting your time right now, but that's fine. Okay, I just found 4 and 5. I missed 3. Where is 3? It's right here. Okay. So in the next video, in the next live stream actually, we're gonna cover we will do the part 3. It says it's 7 minutes, but with me it's 1 hour at least. I will try to explain everything in my power. And I hope you liked my live. If you did, just send a message, comment, ask me questions. I would love to answer any question that you might have. And I also want to, if we're gonna, yeah, when we will finish our antivirus evasion, I would also love to do the malware analysis one. I think he also has like I have seen also four parts, although I have read the first two. It says 15 minutes, so be ready to wait 2 hours for me. And yeah, that's everything. So I hope you have a good one. See you everyone.